Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. This is Mustafa Gamal Abdel Hakim coming to you in another course in coiled tubing. And this course is about coiled tubing operation. This course is an expansion of my previous course, coiled tubing professional course, which we're mainly talking about the coiled tubing equipment, the hydraulic circuits, the mechanism, the mechanics, everything and every control in coiled tubing. You can find my course at Udemy. You can see students number here, rating, and the contents. And this was level 5 of my course, which we were talking about pumping and mechanical operation. In this course, inshallah, we will expand these topics and talk in details because as you can see, the duration of each topic is very little and we don't say or discuss details of each topic. So in today's course, inshallah, we will expand these topics and discuss every detail regarding the rig up BCE, BHA, and operation, inshallah. This course is available in Arabic and English. If you are interested, you can contact me or buy it directly from Udemy in English. So let's move to our course. The course consists of two modules. The first module is pumping operation and second module is mechanical operation. In pumping operation, we will talk about these subjects, inshallah. And we will start in this video with fill removal and second module talking about mechanical operation. So let's start. The fill removal operation. In this topic, we will talk about these points, starting from general consideration and moving down till rig down and post-job evaluation. So let's start each point and discuss it in details. So what is the definition of fill removal? Okay, I put this picture here to illustrate the meaning of fill removal on it. Assume that you are having a well, completion, open berth, and this is a fill, which can be sand fill, can be probant fill, or whatever. So in fill removal operation, you want to pump treatment fluid from your coiled tubing to jet and lift these. We will say sand to lift these sand to the surface at a rate higher than the settling rate because this sand particle will tend to settle due to gravity. So we want to pump treatment fluid at a rate higher than the settling rate of solids and has enough carrying capacity for efficient operation. The fluid pump should have enough carrying capacity. You shouldn't lift 40 pounds of sand and your fluid can carry only 20 pounds. There is 20 pounds of fill will settle even if you are having a rate higher than the settling rate. So this is the definition of fill removal operation. You remove sand fill at rate higher than settling rate and the fluid has enough carrying capacity for efficient operation. Why we do this? To first restore the production. As you can see here, the sand accumulates against the open berth, so it prevents the production from these two berths. So the first purpose is to restore the production from the well. This is the first purpose. Second purpose is to allow wireline intervention and intervention in general. Because if you want to access below this berth, you cannot because the sand fill is accumulated until this depth. So you want to restore the wireline intervention below this sand fill top. Okay. Third point is to maintain enough rat hole. Imagine this is a TCB and you want to shot and drop. You cannot drop at this point. You must clean first, then drop your TCB. Or you allow rack hole to accommodate another sand fill for another period of time. Okay. So these were the reasons of fill removal operation. And always consider that fill removal is totally different from scale removal. In scale removal operation, the scale is reacting with the treatment fluid. The scale will be reacted, okay, and removed to surface. However, in fill operation, the fill will not be reacted or dissolved and will be lifted to surface as it is. Okay, so in scale removal operation, you will dissolve and react with the treatment fluids. However, in fill removal, the whole particles will be lifted to surface as it is. So this is fill removal. The removal methods in general can include jetting and circulation. This is for the least consolidation and size of fill. And as the consolidation and size of fill increases, we can use mud motor and bit, okay, milling operation, or if it has the highest consolidation and size, we can use fishing operation. So in this course, inshallah, we will talk about jetting and circulation. This will be in the mechanical operation in module 2. So let's start with this topic in module 1. So if you have sand particle or probant particle, whatever, it will be affected by these forces. The weight force downward, opposing it, the drag force acting upward, and the buoyancy force acting upward. So these forces will affect the maximum settling rate or fill settling rate of this particle. As you can see here, the maximum fill settling rate is affected by the particle size, shape, and density, which is weight. And when we say weight, we means the buoyant weight, which is the weight affected by buoyancy. Okay, and the fluid viscosity. So these were the factors affecting the settling rate of this particle: the fluid viscosity and particle shape, size, and density. However, the minimum annular velocity, which tend to lift this particle upwards, is affected by the fluid bump rate and the annular capacity, because the fluid bump rate equals the annular capacity multiplied by the annular velocity. And the factor that is important for us is the annular velocity. So it can be controlled by controlling the fluid pumping rate and the annular capacity. So these were the factors. And for efficient fill removal, the minimum annular velocity must be higher than the maximum fill settling rate. For example, if minimum annular velocity is 15 feet per minute and the fill settling rate is 70 feet per minute, the particle will tend to move downwards because the fill settling rate is higher. However, is the maximum fill settling rate were 30 feet per minute, the particle will be lifted with relative velocity of 20 feet per minute upwards. Okay, this is why the minimum annular velocity must be always higher than the maximum fill settling rate, and consider that this is minimum and maximum. So let's talk about the consideration for fill removal operation. The first consideration is about penetration rate. So what are the factors affecting the penetration rate of coiled tubing to the fill? The first factor is carrying capacity of clean out fluid. Different fluids have different carrying capacity. For example, water have carrying capacity of 1 pound of fill per 1 gallon of water pumped. For example, if you were pumping with 1 barrel per minute, which is equivalent to 42 gallon per minute, you will be able to lift 42 pounds of fill every minute. Okay, only 42. However, if you were using gelled fluid, you will be able to lift 126 of pounds every minute. Okay, because the ratio is 3 and the foam has higher carrying capacity. The foam has the best carrying capacity. Okay, so the carrying capacity of fluid affecting the penetration rate, and we will discuss this in example here. Second factor is maintaining desired bottom hole pressure. Okay, because when the well is loaded with probant or sand, the density, causing the hydrostatic pressure will be higher. For example, if you were using 8.5 kcl brine, 8.5 ppg kcl brine, the hydrostatic here, if the well is filled with only fluid, will be equivalent to the hydrostatic pressure of 8.5. However, if the well is loaded with sand or probant, the equivalent density will be no longer 8.5. It will be higher. Okay, it will be higher. So the hydrostatic pressure will be higher. Okay, and it may exceed the fracture pressure of the formation and induce losses. So always consider the bottom hole pressure, and don't load your well with probant unless you make calculation to make sure that the equivalent density and the equivalent hydrostatic pressure will not induce losses in your formation. Third factor is jetting action. You must first have enough jetting action to allow penetration. You can't penetrate in something that is not jetted. You must jet it first to be lifted off bottom, as you can see here. Then you penetrate. If it's not lifted, you cannot penetrate it. Okay? So this is for penetration rate consideration. Let's see this example. For example, if you have fill with specific gravity 2.64 and you are pumping with rate 2 barrel per minute, which is equivalent to 84 gallon per minute, and you are conducting clean out operation in 7-inch casing with this ID. Okay, in this case, there will be 34 pound of fill in every feet on casing. In every feet, you will have 34 pound of fill, and this is calculated from the specific gravity and the capacity of 7-inch casing. So if clean out fluid is water, it can carry 84 based on this rate and this carrying capacity. It will carry 84 pounds of fill every minute. Okay, so dividing 84 by 34, you can penetrate the fill with speed 2.4 feet per minute because it can carry 84 per minute and every feet have 34. So dividing this by this, you can penetrate with penetration rate 2.4 feet per minute. Of course, there are other factors to consider, like bottom hole pressure and annular velocity is enough against the settling velocity. But this is simple calculation to understand the concept of penetration rate and how to calculate it. So I hope you understand this point. The second consideration is reservoir consideration. Reservoir consideration is pressure, temperatures, and sensitivity. Starting from pressure, because this is the most important factor in reservoir consideration. As you can see in this case, formation pressure PF, formation pressure in this case is very low. So circulation cannot be established or maintained at surface. As you can see, the fluid level is here. There is no return at surface. So in this case, your fluid or your treatment fluid or clean out fluid is heavier than the formation can support. You must use lower density fluid. Okay, in this case, you must use lower density fluid. For example, if you're using brine, you can consider using foamed fluid or staged fluid because it will exert lower hydrostatic pressure on the formation, unlike this heavy fluid. Okay, but if you're using the most light fluid or the lightest fluid, like foam, for example, and even with foam, you cannot establish circulation due to losses or depleted formation. In this case, you can use any material that can block this formation temporary, okay? Like, for example, not non-damaging salt plug. You can place it across the perforation. And in this case, you can maintain fluid level at surface because the salt plug will temporarily block the perforation. Okay, this is the first case. Second case is formation pressure is higher than the bottom hole pressure or the pressure exerted inside the well. In this case, you will gain oil or gas or whatever inside your treatment fluid. For example, if you're using foam fluid, mixing foam fluid with oil will degrade and break the foam. So it's not desirable to the formation pressure to be higher than the bottom hole pressure. The third ideal case is when you have bottom hole pressure slightly higher than the formation pressure, usually with 200 psi over balance, but not always, okay, according to the permeability of your formation. So in this case, there is a small losses rate inside the formation, but manageable, okay, and you can establish and maintain circulation at surface. So this is the best case, and we want this case in our operation. Okay, okay. The bottom hole pressure here means the hydrostatic pressure of fluid and fill, considering the propellant loaded fluid, and plus annular pressure losses caused by circulation. Because when you are circulating, you are exerting back pressure on the formation, and this term is called annular pressure losses. And this term is calculated based on rate and pressure, etc. So you must always consider annular pressure losses term in bottom hole pressure to avoid fracturing and inducing losses in your formation. This is the first factor. Second factor, temperature, because treatment fluid will be in contact with the formation for a long exposure, because the pumping rate of coiled tubing is relatively lower than usual strings of drill string, for example, or compression string. So the fluid will be in contact with formation for a long time and the exposure will be longer. So it may cause degradation of the fluid. So ensure that your fluids will be compatible with the formation temperature long enough before it breaks or degrades. The third point is sensitivity. For example, some formation is sensitive to fresh water and will cause clay swelling. Okay, so you must, in this case, inhibit your treatment fluid, to avoid making damage to the formation. And some fluids can cause emulsion or scale with the formation fluid. So always consider the sensitivity of the formation and the formation fluids to avoid damage to the formation and the formation of emulsion and scale. So these were the factors of reservoir consideration during fill removal operation. See you next video inshallah. Assalamu alaikum.